Hi, my name is Todd Christel, and I'm going to be doing a couple of videos here on using Microsoft Robotics Studio and the Kinect to do skeleton tracking. Now, one of the most compelling reasons for using Robotics Studio is the fact that it does support Kinect, and one of the fastest ways to get to the Kinect is through Visual Programming Language, or VPL. However, there are some not so obvious things on using it, and I know some people have had some problems with that. So I'm going to go through a quick explanation here and get tracking running on VPL, and then also through the series of videos. Turn it into a follow me event for Eddie, which is Parallax's robotic platform designed for Robotics Studio. So, to start talking about VPL, I'm going to actually move back and talk about using Visual Studio, the C# version. Uh, when I started working with VPL, and using the Kinect service, I made some programs. They would work some of the time. They wouldn't work. I'd move into the view of the Kinect, and I would be tracked, and then I'd move out of the view, and then I'd move back in, and then it wouldn't be tracked, and there didn't seem to be any rhyme or reason on why it was or was not working. So I read some books and some online articles and started playing with some programming in C# because to me that was a little more obvious way to figure out what was going on. And so I ended up writing a tool, which is on the screen right now, which started out very simple, and a lot of things have been added since then. But I'm going to use the same tool to give you the explanation. When we look at this, the only fields that we're really worried about is the tracking state here. You can see it's not tracked, and this number 2. Now we're also going to be talking about these 3, mostly position X, but we're starting off with the tracking state and 2. And here's the deal: the Kinect uh, tracks 6 bodies, 6 forms, and the SDK allows you to get skeleton information from 2 of those. So that skeleton data is sitting in an array of 0 through 5 to have its 6 elements. And so when the Kinect actually gets a tracking on a body, it gives it an ID in the array. And so I'm going to step in front of the Kinect here, and you can see that it is tracking me. Now you may have noticed that number that I told you about that was a 2 is now a 1. So it was in a non-track state, and then it finds me, it locks on, and it decrements the number and goes to a 1. So I guess I'm going to hop down. Well, I'm going to get out of the viewpoint of the Kinect, and I'm not tracked anymore, and I get back in the viewpoint of the Kinect, and it goes to 4. And that is the real problem. I don't know exactly what the algorithm is, but it's going to, for a person, it's going to lock on to one skeleton in the array, and that's going to be a number from 0 to 5. And if you're not looking at the correct skeleton data, of course you're not going to see any position. So that is the confusing part, and it's also the confusing part of VPL. So that is non-deterministic as far as I can tell. So we look at below that, there's 2 kinds of tracking in VPL. One of them is tracking of the joints. The skeleton has got 20 joints. There's documentation online that lists them, enumerates them. But it'll also track the center of mass of the person. And that's what I'm looking at right here on the second line where it says position X, position Y, and position Z. So X is to the right and the left of the Kinect. Y is, of course, up and down, and Z is the distance away from the Kinect. Now, I think of everything from the Kinect's point of view, as though I was standing behind it and looking out. So if I move to my right, I'm moving to the Kinect's left, and you can see position X is changing. Y doesn't change very much because I'm not moving up and down too much. And if I move to the Kinect right, you can see I'm going to get close to 0 here, which means I'm just about centered. Pretty close. And then it goes negative, and it goes negative across. Now I'm going to go, okay, so also position Z, I guess as long as I'm here, I'm at 1.22 meters away. If I step back, I'm going to 2 meters. The specifications, I believe, say that it goes out to about 15 feet. Maybe more importantly, if you're playing with robots, is how close I can get. Because if I get much closer, then well, that's doing pretty good. I got to point 0.8, and it lost my skeleton. They really say about a meter back is where it works. Now, I backed up and it caught me at 1.5 meters. Here my range, if I go negative, I'm gonna walk off the edge of his field of view on Eddie right, and read that here, 0.6. Now once again, I'm about a meter and a half away. If I move back farther, the number will go to 1 or a little over 1. And of course, if I go to Eddie left, I'm going to go to about 0.7 before he lost my sight. So that's Visual Studio, or C# program, showing what's going on. So let's look at VPL and pull this down out of the way here. Temporarily, I had that up for illustration. It's a fairly simple program. I have the Kinect service that I pulled up from the services area here, and I have a timer set up, and the initial value that I'm putting into the timer is 5 seconds. I found that if I tried to do something too fast, I get the Kinect confused, and so it's got to fire, it's got to initiate and get ready to go. So 5 seconds is just a real nice safe time. So in 5 seconds, the timer fires and does a query raw frame from the Kinect service. At the same time, he resets the timer for 200 milliseconds. There we go, 200 milliseconds, and then gets in a firing loop at that point. So I'm doing a read from the Kinect every 200 milliseconds. I have a simple dialog box here that is looking at any faults coming off of the Kinect. I've not seen any, but always good to do that, especially when you're playing around. So we've done a query raw frame. So where does the skeleton data live? So we're going to do this here. Bring up a calculate frame. Of course, we want to come from success. Go right there. And we go into calculate and look for my options. So I'm going to click inside of calculate. And I did a query raw frame. So raw frames is probably what I want to see. So we'll click raw frames and we'll start expanding that out. So we raw frames and put a period. Probably should have my there. Put a period. And we have color frame data, depth frame data, and skeleton. And we're interested in skeleton right now. And put a dot to expand it. And look there. Floor clip plane, frame number, skeleton data. That looks like a good choice. Now, I know this in advance, but we're going to just keep on like we were. Skeleton data point, fixed size, length, long. Suddenly we run out of options here that are interesting. And that's because skeleton data is that array that I was talking about. Skeleton data is the thing that holds the five or the 6 tracked bodies, and 2 of which, of course, are skeletonized. So if it's an array, we probably have to index it. So backspace, bracket 0, bracket dot. Okay, now this looks more interesting. Joints. Get IntelliSense going again. Tracking ID, position, joints, tracking state. Okay, well, tracking state's interesting, and we're going to be using that. And position is interesting. And so remember tracking state. We're going to look at position, and then we'll dot, and we have X, Y, and Z. And we're going to be playing with X for this, but this is right and left, up and down, and closer or farther away from the Kinect. So this is what extracts that position information from the raw frame coming out of the Kinect. But the problem in VPL, or the problem with doing this, is that there are 6 elements in that array. So how do you know which one is which? It's probably, there usually is many ways of doing this. I've tried a couple. I've tried to use uh, an array and increment a counter as an index, and that never seemed to work so well. So this is what I have come up with. It's got some flaws, which we'll talk about in a second. Now, what I've done is in the calculate, we'll pick the first one here. Okay, so this looks a little different. It's a subset of what I just showed you. It is pulling out the raw frames, raw skeleton data, skeleton data, and then stops. And so what this has done is this has extracted the first part of that frame, or of the message that is coming off of the Kinect service, and then passing the rest of it on. And so what it's doing then is passing it on to my if statement as a value. And so I say if value dot tracking state. Remember I said that we had position was something we were interested in, and tracking state was something that we were interested in. And this is, so we're looking at tracking state if it's equal to skeleton tracking state dot tracked. And these are values that are part of IntelliSense, and you can pull them down and just double click like I've been doing and bring them up. So so what I'm saying here is I take the information from the first element in the array, 0, and I say if its tracking state is equal to tracked, send a message out to this join box. Now you remember join boxes basically hold messages in queue until it has a message at each of the input parameters there. So if it is tracked, I have a message that then flows out and is waiting in this first queue. If it's not tracked, it goes out the else and falls on the floor. I'm also taking the message that I've extracted so far, which is the information from the first element of the array, and just passing it down into the second part of the join. The end result of this is, and now I'm doing the same thing. We'll expand this out, show you. I'm doing it for the second element, the third, fourth, fifth, and sixth element of the array. And the if statements are the same because I'm just checking for tracked. So basically, I grab 6 copies of the message, I index them, one for each element of the array, and I check to see if each one of them is tracked. If one of them is tracked, the if statement is true, it passes it on to the join, and eventually the skeleton information from the tracked skeleton comes flowing out of one of these and goes to the second calculate box, which is skeleton data.position.x, which is the second part of that message that I showed you at the beginning. And it updates a flexible dialog. So we're going to run this. And there I have my flexible dialog. And I'll get in front of it here. All right, and it's tracked me. Now, I'm a ways away, and this font is pretty small, but I'm going to move to Kinect right, and I'm going to move to Kinect left, and you can see that I'm essentially getting the same kind of tracking information that we saw in the C# program. So this must be working. So I mentioned that this has at least one serious flaw, and that flaw is the fact that I am not differentiating between, remember I can track 2 skeletons, so if What do I do if a second person enters the field of view Kinect? Well, the problem here is that the way VPL works is it's doing a threading for you. So we have a bunch of messages that are flowing, and it's assigning threads to all of these messages. So they're not done in order. It's not this one and then this one that is not evaluated in some sort of a deterministic order. It's just messages are flowing around, which are reasons you have things like a join box. If you need to kind of synchronize a couple of asynchronous messages so that you can start off at with a given set of messages, join does that for you. So essentially, if you have two people in here, you're not sure, you can't guarantee which of those individuals that are being tracked are giving you the tracking data. So anyway, so that's the big problem. Um, but at this point, if you're, this is a starting point to experiment with and just to get it going. We're like I said, we're going to make a follow me service. We're going to eventually take that X data and the Z data and use it to make the robot turn right and left. We'll use the X data to make that decision and the Z data to keep a respectable distance away from the person it's tracking. So anyway, that's the first one. I hope it helps. More information is on my blog, which is in the information part underneath this video. And I also have posted this VPL code on my SkyDrive, and there is a link to that for my blog also. So thank you very much. And like I said, I hope this helps you.